Hi there. My name is Terrence Tipton, and I'm here with my teammates Brian Bumpers, Hamadre Mandal, and Jagan Savaraj. Together, we're a group of University of Washington students finishing our master's program in business analytics. This slide is a quick overview of the program and all the various people that help make this happen. At the same time, we're also consultants working on a program or project with Delta Airlines to improve their flight scheduling. As an overview of our project, we're attempting to create an analytics proof of concept with the business goal of optimizing flight scheduling to increase the number of flights through high throughput gates at SeaTac International Airport. The benefits of this project are numerous. One, obviously more flights through gates means more customers served and increased revenue. However, also more efficiency and proving that Delta could become more efficient means they can earn access to additional gates as they become available, and they're a hot commodity. Additionally, improve customer satisfaction, operational savings, and improved scale are all benefits of this project. We'd be remiss if we didn't take a second to talk about COVID-19. Obviously, it's impacting everyone. We're doing this presentation online versus doing it in person. The airlines are obviously very heavily impacted with a decrease in flight demand. To deal with that, we've been excluding 2020 data from our analysis and focusing on the data from the last couple of years. And we know that our solution will still be valuable and relevant for future periods and able to learn and grow as additional data gets added to it. Our proof of concept here has been going for over the course of 4 quarters, and the rest of our presentation is going to be broken down to align with those 4 phases. Brian's going to talk about our first phase of the business understanding and data architecture. I'm going to talk about our Tableau visualizations and doing some descriptive analytics. Madre is going to show our predictive analytics model, and then Jagan's going to show our prescriptive analytics solution using Power Apps to show the results of that prediction. So without further ado, let's get to it. And Brian, you want to take it away?
Thanks, Terry. I will briefly walk you through our data architecture. Most of the data that we received was from publicly available sources. Originally, we gathered the flight data in the form of an Excel spreadsheet. That data included the arrival and departure data, such as the scheduled date and time for the flight, and the actual date and time the flight landed or departed, the origin, which is where the plane originated from, the type of plane, number of passengers, and the destination. We took the Excel spreadsheet and uploaded it to our SQL Server staging area. Using Python, we were able to connect to the NOAA Weather API and upload the weather data to our SQL Server staging area as well. The weather data included all SeaTac weather for 2018 and 2019 and the data for each airport that the flight originated from. Some of the fields we have included in our weather data is temperature, wind speed, wind direction, precipitation, and snow amounts, to just name a few. From there, we built an automated process that transformed the Delta data and weather data to build out our final modeling data set. We then connected our modeling data set to Microsoft's Azure Machine Learning Studio to build our model. Afterwards, we outputted the results back into the SQL Server so we could connect it to Tableau for our data visualizations and connect it to our flight prediction app we also built. The dependent variable in our model was the difference between schedule and actual time for each arrivals and departures. This is an example of how we calculated our arrival and departure variable. we had a scheduled flight to arrive from San Francisco at 10 a.m. and the actual arrival time was 10:05. That means our arrival dependent variable would be plus 5 minutes. We have a similar calculation for departures as well. In this example, a flight is scheduled to leave SeaTac for Minneapolis at 11 p.m. and the actual departure time was 11:10, making our departure dependent variable of plus 10 minutes. So, as I mentioned earlier, we use Python to connect to the NOAA database and upload the corresponding data to our own database. Another really cool, neat feature is we were able to get NOAA's 15-day forecast for each airport and to feed that into our calculations for our future flight predictions. Now I'm going to turn it back over to Terry to go over the Tableau visualizations we've done.
Thanks so much, Brian. So I'm just going to run through 3 quick examples of visualizations that we used. This is a small subset of our findings that I'm going to show, and all of these were with the question of trying to understand why flights were arriving or departing early or why they're late. Our first visualization here is showing arrival flight delays by city of origin. When we looked at the data, most flights arrive early, and however, there were some cities that flights were prone to arrive especially early. Some of those are highlighted in the blue circles. A second example we have here is looking at ground time by type of plane. When we looked at this, we saw there was a ton of correlation between the size or the capacity of the plane and how long it's on the ground at SeaTac. This makes a lot of sense. Bigger planes, more passengers, more luggage. It takes more time to unload and reload and would be on the ground longer. Third, looking at our schedule versus actual by month. Again, finding that on average, on any month, flights tend to get in early. However, there are certain months where we saw a little bit more deviation in the dispersion of flights coming in or when the flights come in. You see that a little bit in this box plot chart, which shows the concentration of the flights are in that middle, and in August through November, there was a little bit more dispersion. So these 3 examples help to identify the power of why flights are getting in earlier or late. We also use this information to better understand our data for creating our predictive model, and that's exactly what Madre is going to show us now.
Thank you, Terry. So after we cleaned and prepared the dataset, we used Microsoft Azure Machine Learning Studio to create various predictive models on the flight data for predicting both the arrival and the departure delay. The right picture shows how the predictive models look like in Azure Machine Learning Studio. And for our experiment, we used different regression methods shown on the left chart, like neural network regression, linear regression, Bayesian linear regression, decision forest, and the boosted decision tree. So we actually ran the experiment multiple times with different sets of features and figured that the boosted decision tree model gives the best result. So here on the left chart, the yellow bars shows the R-squared value, and the gray line shows the mean value. So lesser the mean error and higher the R-squared value, we get a better model. So as we know, feature selection is an important aspect of predictive modeling. So we did a manual backward stepwise approach to our model. So we actually ran the model on 18 to 20 variables, and then each time we went through the PFI score and then checked the effect on the R-square value, and then removed each variable and run the experiment to finally get the list of features with the maximum R-square value. The left chart shows the PFI score for different features. in the boosted decision tree model for the arrival prediction. And we see that both flight data and weather data have significant impact on the arrival prediction. Similar to arrival prediction, we ran multiple regression methods for departure delay. And here also we observed that the boosted decision tree gives the best result with the highest R-square value. And the right chart shows the significance of the different features for departure delay prediction. Here we see both flight data and the weather data have significant impact on the departure delay prediction. And now I'll hand over to Jagan, who will give a quick live demo of the Powerapps.
Thanks, Imodri. Let me share my screen. So we have deployed the results of the prediction models Himadri had shown on the previous slide and developed an app using the training data set from the historical data using Powerapps to display arrival and departure information estimations to enable the business owners to interact with the results of our predictions. So let's look at the arrival flights. So this displays the list of flights on a particular time and date. So these results can be filtered based on date and time. And once you click on this record, you should be able to, the whole flight information of a particular record is displayed. And the similar model is implemented for departure flights as well. Potentially, we believe this app will be really helpful in putting our prediction in the hands of our business owners. And this app uses SQL servers in the backend to connect to the database seamlessly. I'm going to hand it back over to Terry to continue with the rest of the presentations. Let me stop my screen share.
Thanks so much. That's really great. I think we're seeing a lot of value there and being able to, the quality of creating our prediction, understanding the factors, and then displaying it in a very cool tool like Powerapps here. So I just have one more thing. It's like Steve Jobs here, one more thing. This is a Tableau visualization that we're creating to better understand the correlation of how those two models that Himadri talked about and Jagan talked about together. So this shows a number of flights and both our arrival prediction and departure prediction of how much we expect them to deviate by schedule. By combining this data and putting it in one view for a particular day and hour, this provides a view that would help someone that does scheduling at Delta or business user look across this and say, okay, which flight might be most appropriate to schedule on some of those key gates, or oppositely, which flights you might want to stay away from. This last flight in the example, in the yellow bars, tends to arrive a little bit late in our prediction and also depart late. Probably not a great example to schedule on a key gate. The first 7 examples all arrive early and depart almost exactly on time. Those would be much better examples of flights to schedule. So hopefully this just paints a picture of one way that we're able to pull it all together, create a prediction, serve it up in Tableau. We really hope that these solutions and the insights into their business will help Delta out, as well as just help give them a better understanding of how they can use analytics in general to enable continued success across their business in general. So that's all we have. Thanks so much for listening. If you want to hear more, we would love to field your questions in our breakout session via Zoom at 1 o'clock. So come join us. We'll be there, and we hope to see you there. Thanks so much. Have a great day, all.